Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to learn about algorithms. Algorithms are very important. Algorithms are basically step-by-step procedure. Now what do you mean by procedure? Now for solving any kind of task or any kind of problem, we have a set of instruction. So procedure can be said as set of instruction. Algorithm is a step-by-step procedure which you are going to follow so that a particular task is solved. Let's take an example. We need to add two numbers. So whatever the set of operations we need to follow is we get the values of that numbers. Let's take an example. We are going to store the values in two variables. Variable one is A and variable second is B. So I need to get the value of A. I need to get the value of B. Next step would be addition of them. So for storing the value of addition, I need to get the third variable. Let's take example, we are going to take the variable C. So the algorithm becomes taking the values of A and B from the user. Next step becomes the addition of A and B. And next step is storing the value of addition in the variable C. And the last step would be displaying the value of addition which is stored in variable C to the user. If you look properly, I have given a step-by-step procedure. If I misplace some steps, let's take an example, I am misplacing the third step which is the addition of the numbers. Without taking the inputs, how can I add the numbers? So algorithm is basically a step-by-step procedure which defines the set of operations can be performed so that we can solve the given task. Algorithm is not a complete program. Algorithm is just the logic which we need to implement so that the particular task can be solved or the problem can be solved. Algorithms are generally created independent of the underlying programming languages. We provide the logic needed to solve the particular problem. The programming language can be either one. It can be C, it can be C++, it can be Java, it can be .NET. But algorithms is independent of the language to be used. Algorithms are represented in the pictorial form using flowcharts. And if you want to write down the steps, we are called it pseudo code. So algorithm can be also represented in pictorial form and it can also be represented in a step-by-step manner. Algorithm is not a complete program. Algorithm consists of your basic logic which you are going to implement to solve the problem. Now from the data structure point of view, we are going to categorize the algorithm which are very useful for us. First one, insert. As the name suggests, insert is to insert the data elements into the data structure. So algorithm related to inserting the data elements into the data structure is called as insert. Next, search. As the name suggests, search is to find out something. Now what are we going to find out? We are going to find out the data elements which are going to store in the data structure. So algorithms related to finding out the data elements in a given data structure is called as search. Next is sort. Sort algorithms are basically to have the data elements arranged in some order. It can be ascending order, it can be descending order, or it can be user defined order. Next is update. Update is what we are having some values. We are going to change it. So algorithms which are going to study in this one are going to be finding out the given value, making the manipulations, or I can say making the changes as per the user requirements and storing it once again. These are called as update algorithm. And the last one is delete algorithm. As the name suggests, delete is to delete the existing data elements. So the algorithms which help us to delete the data items in a given data structure is called as delete algorithms. Next, what we are going to study is the characteristics of each and every algorithm. Each and every algorithm should follow this characteristics. If we follow this characteristics only, then only we can say the given algorithm is the perfect algorithm, or it can be termed as a algorithm. So the characteristics number 1, first, unambiguous. Each and every algorithm should be clear and error free. What it means? It means each step should provide me some direction. Each and input given and whatever output I'm going to should have only one meaning. That is what unambiguous is. Each and every input given, the values which are going to store should have a clear meaning. It should not be two-way values. It cannot be three-way values. It cannot be four values. Each and value should be clear and concise. Next characteristics of a given algorithm, of any algorithm, is input. All the values which are required for the algorithm should have well-defined inputs. It can be 0, it can be 1, it can be 2, but it should have well-defined inputs. Next, third, output. Just as I mentioned, inputs should be well-defined. That's like only output should be also be well-defined. All the algorithms should have well-defined algorithms output. It can be provided in one way. It can be provided in one value. It can be provided in multiple ways. It can be provided in multiple values. But all the values should be given to the user in a proper format. Output. Next, a characteristic of an algorithm is finite. What it means? Each and every algorithm should have a finite set of number of loops which it needs to implement. It should not be a condition where a loop is going on. It should have a finite number of iteration. There should be some condition where the loop is going to be break up, so that we can come out of the loop and execute the next set of statements. It should not have an indefinite number of steps. Each algorithm should have a finite number of loops only. Next set is independent. Whatever algorithm you want to write, it should be independent of programming languages. Algorithm cannot depend on one particular programming languages. Whatever algorithm you are going to write, you need to put it in such a format, in such a way, in such a steps, so that implementations can be done by various programming languages. So algorithm is what? Basically a step-by-step procedure to solve a particular problem. Characteristics of algorithms are, next one is feasibility. Feasible, it should make the maximum usage of the available resources. Your algorithm should have a finite number of resources which we can use in maximum ways. So friends, what you have learned today is the characteristics of algorithm. I'm going to repeat once again. First one is unambiguous. What it means? It means algorithm should define a clear value. Next is input. All the algorithms should have well-defined input. Next is output. All the algorithms should have well-defined set of values which are going to be displayed to the user. Next is finite. The number of iterations of the loop should be clearly defined. Next is feasibility. All the algorithms should have feasibility with their resources. And the last one is independent. All the algorithms which are going to use should be independent of the programming languages which are going to use. It should provide just the step-by-step directions to solve the problem. It should not define the logics which are going to be implemented by a particular language only. No, it should be defined by all the programming languages. Now we are going to learn why it is important to analyze the algorithm. What do you mean by analysis of an algorithm? We are going to consider the algorithm based on three criteria. First one is the performance. Next is the time complexity. And next one is the space complexity. Performance analysis. Let's take the example. If you want to travel from city A to city B, there are various modes of transportation: bus, flight, train, or even a bicycle. Now, how going to use it? It depends on the conditions. Just like that, in case of computer science, algorithm which I am going to use depends on the available resources which I have. Just take example, if I have a good set of money, surely I am going by the flight from city A to city B. I don't have that much money, I can prefer the train. Now I don't have that much money, then I can go by the bicycle also. It depends how much distance is between the city A and B. Just like that, in case of computer science, we can have different algorithms for a given set of problems. The algorithm which makes the maximum usage of the available resources is called as the best algorithm for that particular solution. So the performance analysis based on the set of conditions which are going to use the algorithm to enhance the solution. In other words, we can say performance analysis help us to judge the best possible solution, best possible algorithm from the given set of multiple algorithms to solve the particular problem. So performance analysis is the selection of the best possible algorithm. Next set is space complexity. Space complexity is the kind of memory usage you are going to make use of. Memory usage. Let's take example of 2, 1. Integer and float. Integer is what? Integer is a number without decimal point. Float is number with decimal point. So obviously the data structure which I am going to use depends upon the what kind of data type I am going to use. If I am going to use integer, obviously it is going to use lesser set of memory. But if I am going to use float, or I can say double, it is going to use large set of memory space. So if I am not going to use float, or if I am not going to use integer, how I am going to decide? It depends upon the what set of values I am going to get. If I am going to get a numbers without decimal points and I am trying to use the float, I am making unnecessary wastage of memory. So it depends upon the space. Space complexity is basically memory usage. So we get the values of memory which are going to use. Space complexity refers to the memory usage for a given set of algorithm. Next is the time complexity. Time complexity is the run time which you are going to use for a particular algorithm. How fast it can execute your set of operation is going to define the time complexity. Time complexity minimum, better the value. Better the value of your algorithm. Algorithm, just take example, I am going to execute a set of algorithm on 32-bit machine, or I am going to use the same set of algorithm for 64-bit of machine. So obviously whichever is going to be faster one, obviously 64-bit machine. 64-bit machine is going to take 64 bits of data at one go, and whereas 32 bits of machine is going to just take 32 bits of memory usage. Obviously now 64-bit is going to take input high, so it is going to give me better performance. It is going to execute a set of operation within a nanoseconds, and 32-bit also can execute a set of operation, but it is going to take some much more second than the 64 bits. So the time complexity of that 64-bit is very useful for me to execute the algorithm. Obviously I am going to use 64-bit machine. So what do we understand of this? Importance of an algorithm is categorized based on 3 parameters. Performance analysis. Performance analysis is what? Judging the best possible algorithm depending upon the given available set of conditions and resources. Next is the space complexity. What kind of memory I am going to use, how much memory I am going to use is going to define the space complexity. Lesser the memory usage, better my space complexity. And the last one is the time complexity. Time complexity is the execution time I am going to use to give the set of result deserved. So lesser the time of execution, better the time complexity. So the 3 things which are going to learn the importance of data analysis of an algorithm are performance analysis, time complexity and space complexity.